Alright guys, number 10, we have that Rita is playing a game, and in the game she must roll a fair six-sided die. Okay, a fair six-sided die. If she gets a 5 or a 6, then she wins a prize. If not, she has another chance, but this time she must flip a fair coin. If it lands heads, she wins a prize. Alright, so it's very important that we understand that first, it's the die, where it's a 5 or a 6 to win, and later on, it is a coin. And in this coin, da da da, if it's heads, she wins. Okay? So that is the key information we have to consider. And for part A, we need to complete the tree diagram by writing in the three missing probabilities. Now, notice how in this tree diagram, we're very used to having something that looks like this, right? And in this case, we have just this. The reason for this is because we only go as far as winning. The moment she wins, she does not need to throw the coin. Alright, so first thing first, that's why this tree diagram looks a little bit weird. On this version of winning, we don't care about throwing the coin anymore because, well, she already won. Okay, cool. The second thing we have to consider is that for tree diagrams, the probability, okay, of each of these little sort of like sticks is gonna equal 1. Okay, so this plus this equals 1. This plus this equals 1, and this plus this equals 1. Why is this useful to know? Because now, for example, if this is 1/2, then this is also 1/2. Why? Because 1/2 plus 1/2 equals 1. Why does it need to equal 1? Because 1 as a percent is 100%. And in probabilities, technically, you consider all scenarios. And so here, like this two blue circles is all scenario. The scenario of winning and not winning has to equal to 1, has to equal to 100%. So 1/2 plus 1/2 gives you 2 over 2, which is 1. There's your 100%. Okay, so again, for tree diagrams, each of these sort of sections has to add up to 1. So over here, I can put this 1/2, perfectly legal. And now we need to fill in the information for the die. So the die that I have in green, let's recall that she says that if she gets a 5 or a 6, she wins a prize. So what is the probability of rolling a 5 or a 6? Well, a dice has 6 sides. 1, 2, 3, 4, 5, 6. And each side has number 1, number 2, number 3, number 4, number 5, number 6. So think about it this way. From 1 through 4, she loses. So here, lose, 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 lose. And here is win and win. What's the probability she wins? Well, it is 2 over my total. So it's going to be 2 over 6. You can think about it this way. It's 5 or 6 divided by your total. So 2 over 6 is the same as 1 over 3. So that was a little bit of a more perhaps like longer explanation. But the point is, for winning in the die, it's going to be 1 over 3. And so for winning is 1 over 3. For no win, it's going to be 2 over 3. Because that is what adds up to 1. For some of you, it might be more intuitive to leave it like with the total amount. So if you want, you can leave it as winning is 2 over 6 and no win is 4 over 6. Both of them work. You don't have to simplify the fraction. The IB doesn't care about simplifying the fraction. Okay? I'm going to leave it simplified because later on it's just easier to do the math. Okay? So win is 1 over 3, no win is 2 over 3. So that is for part A. For part B, we need to find the probability that Rita does not win a prize. And so in probability, it's very, very important that we always consider the different scenarios. So the obvious question is, which is the scenario, or which are the scenarios where Rita does not win a prize? And so it's very important that we consider the whole tree diagram. So in this case, what a lot of people would commit as a mistake is say, okay, probably no win, 2 over 3. And they think they're done, right? And I would say, So first, it's no win on dice, but then it's no win on coin. So it would be 2 over 3 times 1/2. In other words, 2 over 6 or 1/3. So that is a probability of not winning a prize. Now I'm sure there's at least one of you thinking, dude, I just never understood why you multiply probabilities and when do you add them? What the heck is going on? Guys, when you multiply, it is because you're thinking in the word and. And if you add, you're thinking in the word or. So think about it this way. If I think in terms of and or, okay, it's very important. Think in terms of and with or, okay? So if you think in terms of and or, the probability that, or the scenario where Rita does not win a prize, the scenario, careful, the scenario where she doesn't win a prize is no win die and no win coin. So what's the probability of no win die? 2/3. And gives you the multiply, and no win coin is 1/2. So 2 over 3 times 1/2. 2 over 6, 1 over 3. Same thing I did up there. See? So that is one way to think about it. If you think in terms of and or, and is multiply, that is going to put 2/3 times 1/2. Okay? The other way you can think about it is that in a tree diagram, if you want to reach like the coin no win, you have to go through die no win. So you have to do 2 over 3 times 1/2. Okay? The only sort of place where you would be adding is if you consider, I don't know, the probability of no win and the probability of no win die and no win coin, and maybe this line here. See? Then you might be adding this one, like this whole line, with this whole line. But for this example, we don't face that. If you want to find an example like that, I'm sure there's one on my channel. Just look up tree diagram for the buzzword and you'll find it. Anyways, whatever. For part B, it's 1 over 3. Okay? This 1 over 3 here, or this 1 over 3 there. Same idea. Then for part C, it's a little bit more weird because there's a buzzword, given. And so given is an important buzzword that needs to immediately tell us that we are thinking of conditional probability. Okay? And so given that Rita won a prize, find the probability that she got a 5 or 6 when she rolled the die. And so of course this one is way harder. See? And it's very important we understand how to think about given probability. So let me show it super visually for now. Imagine you have a Venn diagram, okay, where you have A and B here, A and B. So I'm gonna do another Venn diagram right away. Okay, the same scenario, A, B. If I am looking for the probability of A and B, what is your total? Your total is this whole thing. So this is where you're drawing from, okay? This is your whole total, and this is A and B. Okay? For probability of A given B, okay, this little stick here is for given. For probability of A given B, it's because you are drawing from B. So because you are drawing from B, what is the probability that you get A? And so notice what happens in given probability. In given probability, where you draw from decreases or changes. And for us, it's always going to be decrease, okay? So in other words, your denominator decreases, okay? And strictly speaking, there is a formula for this. If you go to conditional probability in your formula booklet, there it is. So probability of A given B, remember this is A given B, you have A and B divided by B, okay? So the second one goes on the denominator, okay? You can use the formula for this and it would work. And maybe I will do it that way, I'm not sure. But you can also think about it as just your denominator changing. You have to change from where you, like your total, see? And so in this case, actually, what is your given? You have given that Rita won a prize. And so technically here, your B is that she won a prize. Okay, so winning a prize, if she won a prize, what's the probability she rolled 5 or 6? So technically, just so that we understand very well what's going on, my new universe is only when she wins. And so your new universe is like you're drawing from this and from this. Okay, so that is your universe now. It's only the scenarios where she wins. All right? And so where she wins, what's the probability she got a 5 or a 6? So if she gets a 5 or a 6, she straight up wins, right? But your new sort of set of scenarios is the 2/3 and the 1/2, right? And so a way you can think about it, and I think it's more friendly if we actually use the equation for this one, you can think about it this way. So the equation is that probability of A given B equals probability of A and B divided by the second one, probability of B. So again, this little stick is given, right? So given that Rita won a prize, that means that B is going to be my given. So you can have that, well, your A is going to be everything else. So your A is going to be getting a 5 or a 6, right? Now getting a 5 or a 6 on the die is winning on the die. All right, whatever. So 5 or 6 on die, given, win. So that means you have the probability of 5 or 6 die and win divided by probability of win. Okay? Now, the one on top, 5 or 6 die and win, is just this part here. Probability of die and win is 1/3. So you have 1/3 divided by the probability that you win. Now there's two scenarios for winning, right? You have the scenario that is up here, that is the 1/3, or, so it's plus. So you have the scenario where it's win by die, or lose die, win coin. Okay, I'm going to write that down because it's very important. So you have two scenarios for winning. You either have win, think about it this way. Scenario 1 is win die. Scenario 2 is lose die and win coin. So the two scenarios for, so these are the two scenarios for winning, right? So if I go ahead and say, okay, scenarios for win, or better said, so if you, how do I say it? So if you combine the two scenarios, the cases where you win are scenario 1 or scenario 2. And so scenario 1 or scenario 2, what was or? Or was plus. It was add. So scenario 1 or scenario 2 means you're going to end up with win die or lose die and win coin. See? So here's an and, right? In other words, win die is 1/3, because it's the one up here, right? This 1/3. Or, it's going to give you the plus. Lose die, so lose die is 2/3. So lose die. And, so it's times win coin. Win coin, 1/2. So this is for finding the two scenarios for winning. See? And we did say that the denominator is probability for win. Oops, my bad. The one on the bottom is probability for win. So that means I have the 1/3 plus this. Okay? I mean, it's that whole thing. So it's 1/3 plus 2/3 times 1/2. All right? So that means if I combine the stuff on the bottom, I end up with 1/3 plus 2 divided by 6, right? And from here, I mean, you can just work around with fractions and stuff, but you can also just plug it all into your calculator and forget about it. So in your calculator, you can do alpha y equals, it brings up a fraction. And I need a fractions on top and on the bottom. So I can do it again. Down here, I can do it again. So up top, we're going to have the 1 and the 3. On the bottom, we're going to have the 1 and the 3 plus another fraction, the 2 and the 6. So all of this is going to give you 1/2. So all of this, the probability of 5 or 6 on die, given that you're winning, is 1/2. All right. So that is for part C. Sometimes it's good to think about it from the visual aspect, like the Venn diagrams that I drew, and making your denominator smaller. But you can always just stick to the formula. In this case, for me, thinking about it as the Venn diagram was a little bit harder, so I stuck to the formula. As long as you're rigorous and remember that the second one goes in the denominator, you'll be fine. What do I mean by this? Notice how here the B goes on the bottom, okay? And remember that this stick is A given B. So, in this case, the given, they said it at the beginning. So this is your B, and everything else is your A, okay? So careful with that. The B is whatever is after the word given, okay? It's not always going to be given in a logical order. Sometimes they're going to first say given, so they're first giving you B. All right, careful with that. So remember, this little stick means given. So given B is a way to find it, okay? Anyways, enough blah blah. That is for part C. Notice how it's worth 3 points. You gotta know given probability, okay? It's a little bit harder, but it's a lot of points for just understanding it a little bit better. And knowing how to do a tree diagram gives you 2 whole points. It's not a bad deal, is it? Alright guys, that is for number 10.